Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. We are given a sorted array and our task is to find frequencies of all the elements present in an array. To better understand this problem, let's see few examples. In first example, the array is given as 1, 2, 3, 4 and you can see that all elements are distinct. So the output of this input is 1, 1, 2, 1, 3, 1, 4, 1 means all the elements present only one times. In next example, only one element is present in this array. So the output of this input is 1, 1. It means one element appears only one times. In next example, the input is given as 1, 1, 2, 2, 3. Here 1 appears 2 times, 2 appears 2 times and 3 appears 1 time. That's why the output is 1, 2, 2, 2 and 3, 1. In next example, the input is given as 1, 2, 2, 2. Here 1 appears 1 time, 2 appears 3 times. That is why the output of this input is 1, 1 and 2, 3. So I have tried to cover all the corner cases in these examples. So I hope now you have good understanding of this problem. So let's pause the video and think about an algorithm to solve this problem. Alright, let's talk about the efficient approach to solve this problem. But before we move on to the solution, let's do some observations. So the first observation is we are given a sorted array, and this point is really important. Why we have given sorted array? What if we had got jumbled array like this? So here if we have to count frequencies of each element, then it becomes really difficult to count because one number appears here and one number appears here. I have to run a loop for each element to count the frequencies of each number. But if the array is sorted in ascending order, it becomes very easy to count the frequencies. Let me show you how. So we can start from this number that the frequency of 1 is 1. When we come here, we increment the frequencies to 2. And as soon as we found the number that is different than previous number, then we can stop here and simply print the frequency of previous number. And then again start the counting of frequency of this element. So here it becomes very easy to compare the previous element because the array is given as sorted. Okay, so this is the first observation. Now let's see the next observation. So what we have only one number in the array. If we have one number, it means the frequency of this number is 1. So we can simply print the frequency of this number as 1. Now, what if I add one new element to this array? So if we add new element to this array, then there are two possible cases that could happen. And that is, it is possible that AI is equal to previous element, right? Let's say we have this array 1 and 1 and we came here. So this number is same as previous number. So in this case, what we have to do, we simply increment the frequency by 1. Okay, so before the frequency is 1, now frequency is 2. Clear? Now what happens if AI is not equal to previous element? Let's say the array is given as this 1 and 2. When we came to this point, then 2 is not equal to previous element. It means we found new element. So in this case, what we have to do? First we have to print the frequency of previous element. Then we reinitialize the frequency to 1. Meaning this element appears one time. We found the new element. So that is why we we are resetting the frequency to 1. Okay. And then we simply move to next element and repeat the same process again. Okay, so based on these two observations, we have to solve this problem. Now this problem looks very easy, but implementation might be tricky. So let's see how we can implement this approach to solve this problem. So here you can see we have a function find frequency, and this function is taking array as input. Okay, we are initializing two variables here. One is f is equal to 1 and I is equal to 1. F is equal to 1 means the frequency of first element is 1. Because if you have one element, then obviously the frequency of one element is always going to be 1. I equal to 1 means we are simply counting one element and the frequency of one element is 1. And then we are running a loop from next element. Okay. And inside this loop, we are again running a loop to count the frequency of the element. And in both the loops, we are checking if I is less than n. In inner loop, we are checking one more condition that ARR of I is equal to ARR of I minus 1. Means if the number is equal to previous number, then simply increment the frequency by 1 and I by 1. Okay. If this condition fails, means we get new number like this, 2 is the new number, then what we have to do? We have to simply break the loop, print the frequency of previous element and set the frequency to 1 and increment I by 1. What does it mean? We are going to print the frequency of 1, okay, and we have already got this new number, so we set the frequency to 1 and we move to next element. It could be anything, the next element could be anything, okay. Then we again start the loop, and this time our outer loop is going to work and we are going to run the inner loop once again. And in the last we are checking two more conditions if n is equal to 1. So this condition is for if we have only one element, and this condition is for this type of array if we get 1 1 3. I will explain you in a bit. So let's quickly try run this code and see how it works. Okay, if we have array like this 1 1 2 2, these are the indexes, n is equal to 4. Initially value of f is 1 and I is equal to 1. So now we are starting from this element, okay. So the outer loop begins and it checks if I is less than n. I is less than n this time, okay. So we enter into this loop, and then the inner loop also checks if I is less than n. I is less than n this time, and then it checks if array of I is equal to array of I minus 1, means 1 is equal to 1 or not. It checks, and this time these two are same. So we increment frequency by 1 and I by 1, okay. So our I becomes 2. In next iteration we check if element at index 2 is same as previous element or not. So this time these two are not same. So we simply break the loop, we print the frequency of previous element and we reset the frequency to 1 because this is our new element and it appears one time, so we reset the frequency to 1, and then our I becomes 3 because we are increment I here, right? In next iteration we check if 3 is less than 4. Yes, 3 is less than 4 and 3 is also equal to the previous element. So this case also we increment frequency by 1 and we increment I by 1. So our I becomes 4. In next iteration we check if 4 is less than 3. This time it fails, okay, because 4 is not less than 3. So what happens? This piece of code is going to work. It simply prints the frequency of previous element, it sets the frequency to 1 and I equal to 5. Now the value of I is equal to 5. So this time our outer loop is going to fail because 5 is not less than 4. So this is how the frequency of both the elements get printed on the screen. 1 2 and 2 2. 1 appears 2 times and 2 appears 2 times. So this is how this function is going to work. Now talking about these two conditions in the last. So we are checking if n is equal to 1 or not. So what if we get array like this only with one element? So in this case we have initialized f to 1 and I to 1. So our n is also 1. So 1 is not less than 1. So if we run this program, it checks the while loop checks 1 is not less than. So when we run this program, this while loop checks if 1 less than 1 or not. This condition becomes false and we hit this condition where n is equal to 1. So in this case we simply print the frequency of first element, okay. First element is equal to n minus 1, right? Array of n minus 1 is what? First element. So this condition is for if we have only one element. Now talking about this condition, if ARR of n minus 1 not equal to ARR of n minus 2. So this condition handles this corner case. If we have two elements same and we have one element that is distinct at the last. So what happens in this condition? First we are initializing f to 1 and I to 1, okay. Our while loop runs. In first iteration it checks is 1 is less than n, okay, 1 is less than n and previous element is also same, so it increment the frequency by 1 and I by 1. So now our I becomes 2, okay. In next iteration it checks if second element is same or not. This time it is not same, so this loop is going to break and it simply prints the frequency of previous element 1 colon 2 and we reset the frequency to 1 and I to 3. Now I becomes 3, but 3 is not the valid index, okay. So our outer loop is going to break this time. Then but the last number is remaining still. That is why we have written here that if last number is not equal to second last, then we are going to print the frequency of that number. So in this case, the frequency of 3 gets printed using this piece of code, and frequency of 1 gets printed using this piece of code. Okay, so we get the output as 1:2 and 3:1. So with all the 3 examples, we have covered all the corner cases. So this is how this piece of code is going to work, and we get the expected output. Alright, now talking about the time complexity, we are never running this loop beyond n. So both the loops are checking if the I is less than n. It means we are running till n. Okay, so the time complexity comes out to be theta of n, and the space complexity comes out to be theta 1, because we are not using any extra space other than few variables. So far so clear. So before we end this video, let's have a recap of what we have done so far. So we are given a problem and we are given an array, and our task is to find frequencies of all the elements present in an array. So we have seen one approach only to solve this problem, and that approach is the efficient approach. And in this approach, we are running 2 loops to count the frequencies of all the elements, and we are checking if the previous element is same or not. If previous element is not same, then we are simply printing the frequencies of previous element and start the loop again to count the frequencies of next elements. And the time complexity of this approach came out to be theta of n. So this is it for this video. Thanks for watching and see you in the next video.